in Unit 5. So we committed the first half. So good morning to all and welcome you all for the 31st lecture on basic circuit theory. Okay, so last 2 to 3 classes we have entered or we have been discussing resonance, right? Series and parallel resonance. So in Unit 5, the next half is coupled circuits. So let me put the heading coupled circuits. We are going to couple, two inductors. Okay, are coupling inductors. Okay, that we will discuss. So since we are going to couple inductors, first topic you want to discuss what do you mean by inductance, that already you know. Okay, you are having two type of inductance. One is called self inductance. Guys, are you with me?
Yes, sir.
Okay, one is called self inductance. Another one is called in Facebook you might have heard the word mutual friends, right? So similarly, you are having mutual inductance. Okay, so very first topic we want to discuss what is inductance and different type of inductance. We are having two type of inductance, self and mutual. The next one, coefficient of coupling, another interesting parameter. Okay, coefficient of coupling. Okay, suppose we are coupling, assume we are coupling two inductors. How well these two are coupled? எவ்வளவு ஸ்ட்ராங்கா ரெண்டும் கப்புள் ஆயிருக்கு, ரெண்டுக்கு உள்ள பாண்ட் எப்படி இருக்கு? That is explained by coefficient of coupling K. And mutual inductance, it is M. Inductance, that it is L. Okay. On the third topic, we want to discuss dot conversion rule, another coefficient rule. And fourth topic, we want to discuss series and parallel connection, right? Series, what do you mean by series? What do you mean by parallel? Series and parallel connection of coupled coils. If you will connect two coupled coils in series, what will happen? If you will connect two coupled coils in parallel, what will happen? What is the equivalent inductance? That we want to discuss. Quite interesting. And my final topic is, tuned circuits, application of coupled circuit. One of the important application, as we discussed earlier in your FM, right? You are changing the knob, right? Actually, inside one tuned circuit there. We are having what I mean by tuned circuit, that I will explain later. Why is it so called tuned? Because you are tuning, right, to particular frequency. It may be 93.5 or 98.3. So you are tuning particular frequency. That's what is called tuned circuits. And we are having two type of tuned circuits: single tuned circuit and double tuned circuits. But in your syllabus, you are having only single tuned circuit. I will teach you what is double tuned circuit. Okay, just for your knowledge, it will take more than, it won't take more than 2 minutes. So I will teach you what is tuned circuit also. Then only you can understand what is the purpose of single tuned and what is the drawback of single tuned and why we move to double tuned. Okay. So these are all the 5 topics we want to discuss. But really sorry, these two, it is not included in your syllabus. Okay, just purposely I included. So என்னன்னா ரொம்ப டீப்பா போகல, MCQ பாயிண்ட் ஆஃப் வியூ. சப்போஸ் ஏன்னா these 3 topics, the coupled circuit, I think so it won't be fulfilled. Okay, because these two are the major topics. MCQ அப்படிங்கிறதுனால சம்டைம் இந்த 2 டாபிக்ல இருந்து கொஸ்டின் கேட்டலாம். ஏன்னா இந்த டாபிக் இல்லாம என்ன கேட்டா coupled circuit ஃபுல்ஃபில் ஆகாது. பட் உங்க சிலபஸ்ல only 3 topics, 3 and 5. So purposely I included 4, 3 and 4. So 3 and 4 என்னன்னா, derivation லாம் இருக்கும் derive பண்ணாம with the help of final expression how to solve the problem because sometimes there will be chance for asking problems so அந்த பாயிண்ட் ஆஃப் வியூல டச் பண்றேன் ஓகே எம்சிக்யூ பாயிண்ட் ஆஃப் வியூ அலோன் ஐ வில் டீச் யூ டோன்ட் வரி அது ஒரு 10 to 15 minutes எக்ஸ்ட்ரா டீச் பண்ணுவேன் அவ்வளவுதான் ஓகே so now let me put the heading inductance anyone according to my definition what is inductance anyone already I have given the definition for inductance already I have given the definition for three things RLC what do you mean by resistance that you know what do you mean by inductance that you know what do you mean by capacitance that you know now anyone first of all what is resistance which opposes the resistance what it does
Opposes the current.
flow of current okay the keyword is very important opposes the flow of current okay so you know Ohm's law because or when it is opposing the flow of current definitely you know some voltage drop okay take this is my R now this is my I resistance what it does it opposes the flow of current when it is opposing the flow of current obviously some voltage okay drop okay must be there across this resistor so that is given by you know V equal to I times R that Ohm's law you know now coming to inductance what do you mean by inductance opposes என்ன பண்ணும் this time inductance opposes keyword
Sudden change in current.
in current right so this is very important what do you mean by capacitance opposes is a property of a metal is opposes here the keyword
Sudden change in voltage.
sudden changes in voltage thank you ma sudden changes in voltage okay so now coming to inductance okay so inductance it is the property of electric conductor so let me give the definition first inductance it is the property of electric conductor right actually by which so I told earlier the change in current right which opposes the sudden change in current so the changes in current okay so what it does here listen carefully which opposes the flow of current this flow of current definitely it creates okay some voltage so here it opposes sudden changes in current so by which changes in current uses simple word voltage or otherwise it is called electromotive force EMF electromotive force right EMF or simply called it is voltage so this is the definition for inductance right so because of the changes in current that current produces some voltage right how will you make the statement how will you write this is the statement how will you write in terms of equation so now the change in current okay let me take this is my inductance okay L take this current is some I now the change in current okay dI by dt it produces some voltage that is the voltage across the inductor V sub L can I take now this is directly proportional to d by dt as per the definition the rate of change of current change in current produces voltage okay so VL is directly proportional to AT. In order to remove the proportionality you want to introduce some constant what is the constant here you know Ohm's law I is directly proportional to V therefore V is directly proportional to I in order to remove the proportionality you want to introduce some constant that constant is your resistance R similarly here any guess what could be the constant To remove the proportionality,
Inductance.
so that's L times, very good, di by dt. So voltage across inductor VL. This formula already you know, right? The voltage across the inductor VL equal to L times di by dt. That's already we studied, but this is another way. Okay, from the definition, I have written the formula for inductance. Okay, but you know Lenz law. Have you heard about Lenz law? Just for your knowledge, Lenz law. What it says? Lenz law நம்மளை பத்தி சொல்லுது. என்ன சொல்லுதுன்னு தெரியுமா? The generated EMF, right? The generated voltage or EMF, okay, causes the change in current. Opposes the changes in current. Actually, in the voltage எப்படி ஜென்ரேட் ஆச்சு பிகாஸ் ஆஃப் த சேஞ்ச் இன் கரண்ட். ஓகே, இந்த வோல்டேஜ் ஜென்ரேட் ஆக காரணமா இருந்ததே யாரு தான்? அந்த ரேட் ஆஃப் சேஞ்ச் ஆஃப் கரண்ட் டிஏ பை டிடி தான். இப்போ அந்த வோல்டேஜ் என்ன பண்ணுது? அந்த ஜென்ரேட்டட் இஎம்எஃப் தான் உருவாக காரணமா இருந்தவங்களே என்ன பண்ணும்? எதிர்க்கும், ஆப்போஸ் பண்ணும் இல்லையா? ஸோ ஹியர் யூ வில் கெட் ஒன் மைனஸ் சைன் பிகாஸ் ஆஃப் தட். ஸோ ஆக்சுவலி விஎல் ஈக்குவல் டு minus of L into dA by dt. Why this minus? Because the generated EMF opposes the changes, okay, in current, actually through which it has been generated, right? Through which it has been, like as, right? நம்ம எப்படி தமிழ்னா பெற்றவங்க எடுத்து பேசுறோம் இல்லையா, அப்பா அம்மா, அந்த மாதிரி தான் வோல்டேஜும் தான் உருவாக காரணமா இருந்தது யாரு தான்? டிஏபி. பட் அவங்களே என்ன பண்ணுவாங்க? எதிர்ப்பாங்க. அதனால இது ஆக்சுவலி VL equal to minus of L into dA by dt. Okay, so got it? So this is based on Lenz law. So VL equal to actually minus of L into dA by dt. But you know, always you want to take the magnitude, okay, wherever it is required. So now, got the idea what is inductance? As I told earlier, we are having two type of inductance. One is called self-inductance, another one is called mutual inductance. So let me put the heading self-inductance. Okay, and take the situation. I'm having some L and the current is some I. Okay, and here I am having some another real. Let me take this is L1 and this is L2. Okay, what it does in the rate of change of current. Okay, let me give the definition first, then I will explain with the help of the definition. The rate of change of current, what it does, the rate of change of current, it produces voltage or EMF, right? The rate of change of current produces EMF within the same coil. Within the same coil, then it is called self-inductance. Okay, here this I is flowing, right? The rate of change is given by, you know, di by dt. If it generates voltage within this coil, within this L1, that is called self-inductance. The rate of change of current, okay, produces EMF within the same coil, then that is called self-inductance. That is called self-inductance. This already you might have studied, okay, in your physics, but anyway. Now, what is mutual inductance? Anyone? Can you give me the definition for mutual inductance? Please help me. Mutual inductance. Yeah, anyone? Please. You know mutual friends, right? Yeah. Think about that and let me know what is mutual inductance. I have given the definition for self-inductance, and this time you please think and give me the definition for mutual inductance. Anyone, please? Right? Sorry, with me or not?
The rate of change of
The rate of change of
current produces
The
EMF
rate
within
of
the
change
neighboring
of
coil.
current produces EMF. Okay, nearby coil. Now this rate of change of current, it produces EMF. Okay, in L2. In simple words, produces EMF. Okay, and nearby produces EMF in nearby coils. Okay, produces EMF in nearby coils. Then that inductance is called mutual inductance, and it is denoted as L, and this one is denoted as M. Okay, so got the idea what is self inductance, what is mutual inductance. Okay, very definition line which you can just explain your own words. Now coming to the formula for self inductance, derive the formula for mutual inductance. Yeah, it is given times number of turns. This is flux H divided by where N is number of turns. Okay, in coil. You know what do you mean by coil? What do you mean by inductor? Take one connecting wire. The form of you seen coil in the fan? Fan ஓடிட்டு இருக்கு. Hear the word coil எடுத்திருக்கேன். என்ன பண்ணுவாங்க தெரியா? காப்பர் வயர் இருக்குல்ல, inductor and the coil doing nothing but inductor, right? Number of turns, yeah, number of turns. Okay, as per physics it flux, so here phi is nothing and I, so this formula actually we are going to derive. So it came that, okay, explanation here. Now take this is my inductor L, and the current takes some I. Now the rate of change of current di by dt. Okay, actually have you heard Faraday's law? Faraday's law. As per Faraday's law, now the rate of change of current, right, this di by dt, it produces some flux. Actually in the form the மாதிரி இருக்கும். It produces some flux. Okay, this d, this flux is denoted by phi, so d phi by dt. Okay, so here the voltage V is directly proportional to the rate of change of flux linkage d by dt. And in order to remove the proportionality here, okay, actually here the proportionality is number of turns. So V equal to n times d phi by dt. So here also as per Lenz law, the generated EMF opposes, okay, the rate of change of flux through which it has been generated, the same concept. So here V equal to this concept. Okay, so already we know what do you mean by inductance. Take equation number 2, and now take, this is already we derived one more thing. Take equation number 1. Now both are equal, right? So here also actually it is V sub L, voltage across inductor. Now equation substitute, equation number 1 equals to equation number 1, what it says, minus of L into di by dt equals minus of n into equation 2 d phi by dt, where phi is nothing but flux linkage, right, with that coil. So now this d by dt get cancelled, minus minus get cancelled, so remaining this is L times I, which is equal to n times phi. Therefore I'm looking for L, so L equal to n phi by I. Okay, Henry, right? Unit. So this is the way to derive the formula for self-inductance. In some book, they have given L equal to, psi divided by I, where psi equal to N into phi. This is total flux linkage because phi is the flux linkage, right? This is my flux linkage with the coil, and this flux linkage is multiplied with N, so it will give you total flux linkage, right? Number of turns into flux linkage with that coil. So some book they have given psi divided by I. You might have studied in your physics, okay, +2 physics. According to me, it is N phi by I. I will know why I am using this formula, why not that formula. I never use this formula, just for your knowledge, okay? But I will use this formula, that I will explain why. So this is the way to derive the formula for self-inductance, right? This formula is very important. It is N phi divided by I. Now coming to mutual inductance, M. Mutual inductance, M. Let me take, okay, two coils, right? Minimum I require two coils for mutual inductance, right? So take coil 1 and take coil 2. Okay, take L1 and this is L2. And take this current is some I1 and this current some I2. Here I am applying some voltage V1 plus minus. Here the voltage V2 plus minus. Okay. Now, what is mutual inductance? Anyone? And here the number of turns it is N1, right? Here the number of turns it is N2. Okay. And you want to know one thing. Phi, it is the flux. Phi 1, what is phi 1 and what is phi 2? That you know. Phi 1 flux links with coil 1. Flux phi 2 flux links with coil 2, right? This is coil 1 and coil 2. Now I am going to give you one more term, phi 1 2. What is this? Any idea? Because of this current I1, okay, it produces some flux, okay, in the nearby coil. How will you denote this link? Okay, phi 1 2. What is phi 1 2? I will give the definition. Phi 1 2. This is flux links with coil 2. Second number indicates coil. Okay, coil 2. Because of current which is flowing through coil 1. So first one is current, okay, at coil. So now can you let me know what is phi 2 1? Anyone? Phi 2 1. You want to know four things: phi 1, phi 2, phi 1 2, phi 2 1. So phi 1 nothing but self inductance at coil 1, phi 2 self at coil 2. Okay, phi 1 2, this is a flux links with coil 2. Second digit indicates எங்க flux இருக்கு அப்படிங்கிறது. First digit indicates because of which current. Okay, so what is phi 2 1? Anyone? Phi 2 1 flux. Anyone please? Links with coil because of current at coil. Can you fill these two dash? Anyone?
The flux links with the coil 1 because of current at coil 2.
Okay. So now, how will you define mutual inductance? Okay. First, what is this V1? That is generated. I am writing the formula for V1. Okay. Voltage generated at coil 1. It is because of the current which is flowing through coil 1. It is directly proportional to dI1 by dt. In order to remove the proportionality, it is VL equal to so dI1 by dt. As per Lenz's law, it produces, okay, it which opposes certain, which opposes the rate of change of current. So V1 can I write minus L1 into dI1 by dt, our old formula. Now, because of, okay, this I2, you will get some flux, okay, links with coil 1 because of, so now because of the change I2, I will get some current, right? I will get some voltage generated, okay, at coil 1. So now this time V1 is directly proportional to the change of current which is flowing through coil 2, nearby coil. So this time, how will you remove the proportionality? In order to remove the proportionality, you want to introduce some constant. This time, constant is called actually mutual inductance, right? So this time it can be replaced by di2 by dt. As per Lenz's law, it also equal to, so take equation number 4. Okay, this is self and this is because of mutual. Now equation 3 equals 4, right? Since you know both are V1, so minus of L1 into dI1 by dt equals minus of M into dI2 by dt. Okay, now this minus get cancelled, d by dt get cancelled. Okay, actually here only one change. Okay, so this is actually because change, because of the current change actually it produces the this flux is actually 1 2 or 2 1 because of, okay, the current which is flowing through coil 2, it produces some flux, okay, at coil 1. Is it 5 1 2 or 5 2 1? I repeat the statement, because of the current which is flowing through coil 2, because of the rate of change of current di2 by dt, now it produces some flux, okay, 5 at coil 1. So current is 2, coil is 1, right? So it is 5 to 1. Am I right? So actually it can be written, okay, I'm writing from pencil. So equation number 3, minus of L1 into di1 by dt equals minus of M into d by dt. Because of the change of rate of current, actually this is actually 5 to 1, right? 5 to 1. So now minus get cancelled. Okay, d by dt get cancelled. So here I'm having L1 times I1 equals M2 times 5 to 1. Okay, next I'm looking for any doubt enough. I'm looking for M. So this time how will you write M? M you can write sit the way. Are you with me? Actually, listen. I
Sir,
will give you one clue. Okay. Wait. I will give you one clue. What is my self-inductance? How I derived self-inductance? Just to think that self-inductance, I will give you to write the formula for mutual inductance. Now come here. Okay, self-inductance, you know it is L. Now mutual inductance, you know it is M. M equals, okay. If it is I2, okay, the current which is flowing through coil number 2, because of the current which is flowing through coil number 2, it will generate voltage at coil number 1 or 2. Obviously, this is N5, right? Now my question is it N1 or N2? First. Then my question is it 512 or 521? If this is I2, that's my question. From
521, sir.
first N1 or N2? If it is I2, if it is
N1.
I2, N1, N1, okay. So
521.
521, yeah, very good. Or otherwise, if it is I1, at the time obviously it is N2 because the rate of change of current, rate of change of I1 which produces EMF at coil 2. So obviously number of turns at coil 2 N2. So this is 5 1, right? So in simple words, if I want to write M equal to that, if it is I1, so it is N2. Okay, first take this numerator, then denominator. 5 sub A. Okay, so numerator is 1. Sorry, denominator, right? 5 sub Dn. First your denominator is the numerator, it is okay. So that formula you want to read. Okay. Now I want to derive this. So where I did a mistake. Anyone can you help me? Now I want to get okay either M equals here I am looking for I1, right? So I1. So obviously it is N2. Okay. D phi sorry N2. Then obviously it is phi 1 2. I'm looking for this formula. So where I did a mistake, please help me. Just to think. I want to get this formula. So to get this formula, what you will do?
Sir, 512, sir.
512. Okay. So what are all the other changes? Just to think. Others, what you are doing? Please help me. Guys, are you with me or not? Okay. So actually this time I want to derive mutual inductance. Okay. So this is not record actually, first of all. Okay. So let me erase everything. I will start from scratch. Yourself, it is not required here. Okay. Right away, I want to start with mutual inductance. Okay. So here you are having, two voltages, V1 and V2. What is V1? Because of mutual inductance. Because of mutual inductance, okay. So definitely the current which is flowing through coil 2, the rate of change of I2, di2 by dt. In order to remove the proportionality, so it is minus m di2 by dt. It is my V1. This is because of mutual inductance. This is as per property. Now by using Faraday's law, this is based on property. Okay. Now by using Faraday's law, what is my V1? V1 equal to minus of this time. It is the current which is flowing through. I mean number of turns at coil 2. So N2. So D. Okay. Phi by dt. Is it 512 or 521? Where first digit indicates 512 or 521. 512 is flux, இது கொஞ்சம் கன்ஃபியூஸ் பண்ணும். You want to take much practice. Okay, flux links with coil 2. Okay, because of current at coil 1. So because of I1. Okay, but here I need which one? Flux links with coil 1. Okay, because of the current. Now is it 512 or 521? Just think, purpose of the intention of குழப்பிக்கிட்டு இருக்கேன். ஏன்னா ஃபியூச்சர்ல நிறைய குழப்பம். Please come up with the answer. ஏதாவது உளறு தப்பா கூட சொல்ல, I will give you the clarity. So for that time, for that only I am taking this much time. So please. இந்த ஃபார்முலா கரெக்டா இதை ஃபர்ஸ்ட் திங்க். ஓகே, இப்போ இதுக்காக ஆன்சர் பண்ணு. இஸ் இட் 512 ஆர் 521?
சார் ஒரு டவுட் சார்.
சொல்லுங்க.
ஆக்சுவலி ஃபர்ஸ்ட் காயில்ல இருக்கிற வோல்டேஜ் அந்த அந்த வோல்டேஜோட ஐ மீன் மியூச்சுவல் இண்டக்டன்ஸ் ப்ராப்பர்ட்டினால செகண்ட் காயில்ல current
V1 because of okay the current which is flowing through V2, that will give you mutual, right? V1, okay, or otherwise I can write this way: I2 di2 by dt, rate of change of current which is flowing through coil 2. It produces EMF at coil 2 na இது யாரு, coil 1 na இது யாரு? Coil 2 is itself or mutual? The rate of change of 2,
coil 2 na self.
Okay, so this is self. அப்ப இது என்னது? Mutual.
சார்.
அப்ப இப்போ வா. So di2 by dt, okay, it produces some voltage at coil 1, so that is actually V1. So can I write V1 is directly proportional to the rate of change of di2 by dt. Okay, so in order to remove the proportionality, so V1 equal to, so minus of this time, because of mutual you want to write M, right? So V1 equal to minus of M into di2 by dt. இது equation 3 னு வச்சுக்கலாம். இது எழுதியாச்சு. Now as per Faraday's law என்ன சொல்லுது? You know, V is directly proportional to d5 by dt. So here this time V1, okay, I'm writing one more time here, V1 is directly proportional to d5 by dt. My question, this 5, is it 512 or 521? You know what is 512, you know what is 521. One more time I will write it here. 512, இது கன்ஃபியூஸ் பண்ணும், அதுக்கு ஒரு டைம் எழுதிட்டு இருக்கேன். 512 is சிம்பிளா எழுதுறேன், flux links with coil 2. Okay, இது flux links with coil 1. இப்போ எனக்கு என்ன வேணும்? Flux links, sorry, 521. Okay. So 521. Now in order to remove the proportionality, is it N1 or N2? Is it N1 or N2?
N1.
N1. Is it N1 or N2? Is it N1 or N2? Just to think. Anyone else? Is it N1 or N2? Vignesh, you are correct, but anyone else? Is it N1 or N2?
N1, sir.
Yeah, thank you. We want to explain this. So it is 521 by dt. Now this is V1.
With coil 1.
Equation number 4. Yeah, thank you.
So the number of turns of coil 1 தான் affect பண்ணுங்க sir.
Okay. So now equation number 3 equals 4. Where equation number 3, what it says? Minus of M into di2 by dt equals N1 into d phi 21 by dt. Okay. Now this minus minus becomes plus. Okay. This d by dt get cancelled. So I am ending with m times I2 equals N1 phi 21. I'm looking for m. Therefore m equals N1 phi 21 divided by I2. Henry, right? So for mutual inductance also it is another kind of inductance, another type of inductance. So same unit, Henry. Okay. So similarly, can you play with V2? V2. What is the equation for V2? Because of mutual inductance. So obviously it is directly proportional to this time di1 by dt. Okay. So in order to remove the proportionality, it is minus m. So this time V2 as per Ohm's law, sorry, as per Faraday's law, it is directly proportional to d phi. This time 1 to right, phi 1 to divided by dt. So to remove here you want to this time minus n2. Okay. Now equate these two, and you will end up with this time m equals so I1. So this is n2 phi 1 2. Okay, got it. So this is the way to derive mutual inductance. Okay, I will give you the conclusion. This is very important. Okay, you know the formula for self inductance L. This is number of turns phi divided by I. Once if you remember this formula, then M is given by, if it is I1, so obviously it produces EMF at coil 2, so that is N2, then 5 times. First take this 1, phi 2, right? Or otherwise, if it is I2, so it becomes this is N1, so 5, first you take this 2, then 1. Okay, so these three formulas I want to give. Okay, got the clarity? Is are you with me?
சார் கொஞ்சம் மேலே வரீங்களா சார்? எழுதிக்கிறேன்.
வா வா வா.
ஓகே, இங்கே இருந்தீங்க.
Take equation number 3 and 4. And take this is equation number 5. Okay. And 6. Flux links with coil 2 because of di1 by dt. In simple words, I can write. So here phi 21 flux links with coil 1. Okay, because of di2 by dt, the rate of change of current, okay, which is flowing through coil 2. Equation number 3, 4. Now equate 3, 4, you will get this one. Then write equation number 5 and 6. Okay. So one equation from basic property, another equation from Faraday law. Okay. So that's what here I have given property. By using basic property, we develop equation number 3. By using Faraday law, we develop equation number 4. Okay. Just to be clear. So now coming to coefficient of coupling. Coefficient of coupling. Here also you want to be clear, okay? But this time I confuse panana varumbala straight away explain pannirren, you just understand, okay? Now take one more time, I want to draw that coil. take 2 coil. Just understand by yourself this time. Okay, take this is L1, this is L2. This time I want to deal with only flux links. Okay, here the self inductance, you know, that is phi 1. Here self inductance, you know, phi 2. Okay, I am asking you one question. Flux links with coil 2 because of, okay, so flux links with coil 2. This is my coil 2. So coil 2 ulla flux links, okay, because of obviously enna varum current which is flowing through coil 1, right? So because of current which is flowing through coil 1. What is the name for this? Is it phi 1 2 or phi 2 1? Flux links with coil 2. I'm clear this time. So because of the current which is flowing through coil 1 la flow ஆகிற கரண்டால coil 2 ல உள்ள flux linkage-க்கு என்ன பேரு? Is it phi 1 2 or phi 2 1?
Phi 1 2.
Phi 1 2. Okay. So now this coefficient of coupling is given by the ratio between what is the self inductance because of coil 1? It is phi 1. Okay. Now how much mutual inductance, how much flux, okay, is given by this coil 1 to coil 2, that is given by phi 1 2. Okay, so out of this much inductance, out of this much self inductance, it is myself, right? How much I am giving to others, how much I am giving to you? Suppose I'm having some, you know, just to assume I'm having some 100 rupees, I may give some 30 rupees to you, right? Now what is this ratio? This ratio, it will tells, okay, nothing but 30%, right? So I have given 30% to you people. So that is the coupling between you and me, right? Suppose I am giving some 70 rupees. I have actually in my packet I have some 100 rupees. If I will give you 70, then what is our coupling? In terms of percentage, it is 70%, right? Suppose if I will give you 100 rupees out of 100, percentage, right? Strong couple, right? So here this K, in terms of percentage, it is 70, 30, 100. In terms of number, this K may be vary from 0 to 1. Okay, so how will you define K? Out of this much flux, okay, out of this much flux, how much flux in the nearby coil? Out of this much, how much I have given to you people? Got my point? In other words, how will you define K? Either K can be defined this way, or if it is phi 2, at that time it is phi 2. Okay, so now this is the definition, coefficient of coupling. Okay, how well, okay, the flux is linked. Phi equals phi 2. What it indicates, take this formula, 1 equals phi 2. What is K? K equals 1, right? Or otherwise in terms of percentage, 100%. 100 case. Okay, you just think the practical interpretation by yourself. Okay, I don't want to confuse you much this time, so just to take the definition, it is allowed, it is enough. So K is defined either phi 2 1 divided by phi 2 or 2 divided by phi 1. The range is very, very important. Okay, the K maximum 1, minimum 0. In terms of percentage, 0 to 100%. Okay, so got the definition for coefficient of coupling. So it defines how well, okay. So it is a figure of merit, right? K equal some 7%. So from this, what is our understanding? I'm telling I'm having two coils, okay? Take these two coils. I'm telling the K equal to 70%. So what is our understanding? 70% take for coil 1.
That means 70% of
Just to
self
play with numbers. You just to play with your own numbers. You take your own example and let me know what is your interpretation. You come on. The way you started is correct. But at this time, I want to play with numbers. So how will you explain this? Okay, I will say it for coil 1, right? So I will give you some, the flux, okay, at coil 1 is some 70%, right? 70, 50. Now, so take this is 5-1, some 50. Now my question, what is the value for 5-1-2? If the K is 70%.
Sir, that means 512 is 70% of 50.
What is the I'm asking? Yeah, you are correct. 70% of
140.
50. So 70% of 50.
35 years.
Yeah, 35. Okay, so that's the meaning. So this is about coefficient of coupling. Okay, my final topic for today's class. Okay, the relation between, it's another quite interesting relation between this coefficient of coupling and mutual inductance. பழனி கார்த்தி இருக்கியாப்பா? பழனி கார்த்திக், are you there? இல்லையா? பழனி கார்த்திக் இருக்கியா இல்லையாடா? பழனி கார்த்திக் இருக்கியா இல்லையாமா? முதல்ல கனெக்ட் ஆயிருக்கா இல்லையா ஆன்லைன்ல? என்னடா பண்றீங்க?
சார் இல்ல சார் பழனி கார்த்திக்
சார் ஆளே இல்லையா?
ஆளே இல்லையா? சரி இம்பார்ட்டன்ட் பாயிண்ட் சொல்லுவாங்க. சரி சொல்றேன், நான் சொல்லிடுறேன் அப்புறமா. ஓகே, ரிலேஷன் பிட்வீன் K and M important. Okay, as usual I want to give that final expression. The relation is very important. K equals M divided by square root of L1 L2. What is the unit for coefficient of coupling? No unit, right? Unit for coefficient of coupling, no unit, because both are flux linkage, both will be cancelled, so no unit. So if you will derive, okay, the relation between K and M, where K coefficient of coupling, M divided by square root of L1 L2, is sometimes confuse ஆகும். M equal இப்படி கூட எழுதிட்டு இருப்போம், K divided by square root of L1 L2. ஓகே, இத அந்த கன்ஃபியூஷன் அவாய்ட் பண்றதுக்காக.
ஏன் சார் சொல்றீங்க?
இல்லடா, இதெல்லாம் வந்துட்டு நான் பிராக்டிஸ் பண்ணது. இப்போ உனக்கு ஒரு ஐடியா சொல்லி தரேன், அதுக்கு தான் வந்தேன் இங்க. அதுக்கு தான் பழனி கார்த்தியை தேடினேன். ஆக்சுவலா பழனி கார்த்தியை ஏன் தேடினேன் அப்படின்னா, ஆக்சுவலா ஊர் கோயில்பட்டியில என்ன ஃபேமஸ்ன்னு தெரியுமா?
கடலை மிட்டாய்.
கடலை மிட்டாய். ஸோ கடலை மிட்டாய். ஓகே, புரிஞ்சா? ஓகே தான் இருக்கும், அட்ஜஸ்ட் பண்ணிக்க. So K equal to M divided by square root of L1 L2. If you will remember கடலை மிட்டாய், then you won't write M equal to K times, because இது இங்க இருந்து இங்க வரும். கடலை மிட்டாய் நம்ம இங்க இருந்து இங்க போகணும். கடலை மிட்டாய் K equal to M divided by square root of L1 L2. ஓகே, இது இப்போ டெரைவ் பண்ணணும், that is important. So you know what is M, right? M எப்படி எழுதலாம்? Either 5-1 எழுதுனேன்னா this is 5-1-2, இல்ல 5-2 எழுதுனேன்னா this is 5-2-1. It is also M. So now this is M squared, right? Actually, so can I write M squared equal to 5-1-2 divided by 5-1, 5-2-1 divided by 5-2. Now do one thing, multiply and divide this one by 5-1-2. ஏன்னு சொல்றேன். Now rewrite this. எப்படி எழுதலாம்? You know what is L1, right? What is L1 N1 phi1 divided by I1, right? Are you with me? What is formula for L? N phi divided by
N2
I. Nama?
N2
Okay,
5.
okay. N2 la I'm looking for L. L க்கு formula என்ன? N phi by I. Okay.
Okay, okay.
Now I will give you an assignment. You just think by yourself. இதை மட்டும் வச்சுக்கோ இப்ப M you know 512. Actually this is not M. This is K, right? Sorry. K. This is 1K, right? What is K? K equal to 521 divided by 52 or 512 divided by 51. So it becomes actually K. So it becomes K square. Okay, so K square. இப்போ என்ன பண்றேன் இதை multiplying and divided by 5152 divided by 5152. Okay, I want to get this relation. What relation? This relation. From here to here, what you will do? Just think. In between, 2 steps will come. What are all the steps? அதை மட்டும் think பண்ணி பார்க்கலாம்.
சார் ரொம்ப சங்கடமா இருக்கு சார், சொல்லிருங்க சார், முடியல சார்.
இது சங்கடம்னா என்னடா பண்றது? Okay. Do one thing. இதை think பண்ணு. Take M square. What is M? Either I ஒன்னு வச்சு எழுதுனா N1.
N2
So this is N2. So this is 5.
5I12 I1 சார்.
இது I2 வச்சு எழுதுனா
N1 521 சார்.
Okay, very good. So now multiply and divide this one by 51 52 51 52. Okay, now எப்படி எடிட் பண்றேன்னு பாரு. N1 I1 51 N2 I2 52. So 512 divided by 51 521 divided by 52. Can I write like this? M squared எடுத்துக்கிட்டேன். This is my M. This is my M. What is this? L1
K1 K2
L2. K1 K2 nothing but K squared. This is M squared, right? I'm looking for, so எப்படி எழுதலாம்? M equal to square root of L1 L2 times K. Therefore
K சேமா இருக்கணும்னு அவசியம் இல்லையா சார்?
என்னமா? K இதுவும் K இதுவும் K தானமா?
இல்ல ரெண்டு
K1 K2 எல்லாம் கிடையாது.
இல்ல அதோட இது
K எப்படினாலும் டிஃபைன் பண்ணலாம். K எப்படி டிஃபைன் பண்ணலாம்? Because of 5-1 so this is 5-1-2 or otherwise 5-2 போட்டேன்னா this is 5-2-1.
ஓகே சார்.
There is no
வேல்யூ
such
அதோட கோஎஃபிஷியன்ட் வந்து மாறாது சார். ஃப்ளக்ஸ் லிங்க் ஆகுது.
மாறாது சேமா தான் இருக்கும். எப்படினாலும் டிஃபைன் பண்ணலாமா K? Okay, so இங்க வந்து there is no K1 K2, so K squared. So in order to remove this square என்ன பண்ணுவா? அப்ப M equal to square root of L1 L2 K. I'm looking for K, so K equal to M divided by square root of L1 L2. Okay, so that's it for today's class. Okay, இது வேண்டாம். So now just to take the relation between M and K. Take this. So that's it for today's class. Okay. not to give the summary today itself because I confused you people, I know. So anyone, can you help me? What is the formula for self-inductance that you know? N times phi divided by I. From this, it is easy to write the formula for M. If it is I1, so this is N2, so phi on 2. Or otherwise, if it is I2, so this time this is N1, phi 2, 1. So this is my self-inductance and this is my mutual inductance. And finally, we derived the relation between self and mutual inductance. அது ஒன்று சொல்லியிருக்கேன், கடல முட்டை என்ன வச்சுக்க, K equal to M divided by square root of. இவ்வளவுதான் நீ படிச்சிருக்கோம், பெருசா ஒன்றும் படிக்கல. Okay. With the help of these formulas, we will derive the problems by just. Thank you. Thanks for your attention. In case of any doubt, please stay. Otherwise, you can leave. Thank you.
Thank you, sir.
Thanks for your attention. Thank you.
Thank you, sir.
Thank you, sir.
Thank you.